Hello and welcome to another episode of Becoming Multiplanetary. I'm RichLB and I'd like to start by introducing my co-hosts, Kage.
Well, hello. Thank you very much for joining us on this very special episode of Becoming Multiplanetary. Um, I am Kage, one of your co hosts, and this is a special episode because it not only closes our Mars Rover Mega-Series, but it also brings a special guest, a new host from the Total Space Network. Static Firegal, would you like to introduce yourself?
Hey, thanks for having me here. It's my pleasure. My name is Adele or Static Fire Girl, and it's so really nice to be here in this episode. This is going to be an interesting one.
Thanks. That's great. It's great. Going to be great having you here, as well. Actually,
Thank you.
to go through this episode. So briefly, I'm just gonna have a quick recap of what we discussed in our previous episode, which was the opportunity episode. Um, so the episode we have right here, the Sojourner episode, will actually close our Rover Mega-Series, where we've covered all of the major rovers that NASA has sent to Mars. We started the series with the most recent Perseverance mission, which launched on July 20th, 2020, and landed successfully in Jezero Crater on February 18th, 2021. Perseverance is already performing her mission and is set to release the helicopter she carried, Ingenuity, perhaps as soon as April 8th this year. Percy has been active now for 35 sols, which is 37 Earth days, since it landed, and given the wild success of its older sister, may well go on for a decade or more. Speaking of Percy's sister, we next covered Curiosity, which launched on November 26, 2011, and landed successfully in Gale Crater on August 6, 2012. Curiosity is still going strong with 3,071 sols, that's 3,155 total days, or 8 years, 233 days since it landed. While Perseverance and Curiosity have significantly different scientific instruments on board, both share a lot in common with Perseverance, even using spare parts from Curiosity. Both are looking not only for past signs of ancient life on Mars, but are also performing planetary habitability studies to prepare for human exploration. Exploring Curiosity became a two-part episode due to the sheer volume of information there was to cover about Curiosity given nearly its decade-long mission. We then went into two episodes discussing Spirit and Opportunity. These twin sister rovers, Mer-A, Spirit, and Mer-B, Opportunity, were launched on June 10th, 2003, and July 7th, 2003, respectively. Spirit and Opportunity landed on January 4th, 2004 in Gusev Crater and January 25th, 2004 in a small crater called Eagle in the Meridiani Planum Flat Plains, respectively. They both used an airbag landing system, which was first tested and successful with the Pathfinder mission and its Sojourner rover, which we'll discuss in today's episode. Spirit and Opportunity, or OPI, were highly successful, with Spirit lasting for 2,208 sols, or 2,249 days, which is 6 years, 77 days, and OPI lasting a whopping 5,110 sols, or 5,250 days, or 14 years and 136 days. And now, that brings us to the rover that started it all, Sojourner, and the Pathfinder mission it was a part of. And Adel, would you like to tell us about that?
Okay, so about the Pathfinder mission. The Mars Pathfinder, or they call it Missour Pathfinder, was a Mars mission consisting of two major components: the Pathfinder base station and the microwave-sized Sojourner rover. It was called Missour Pathfinder as it was part of the Missour program, which stood for Mars Environmental Survey, intended to be a set of 16 surface missions on Mars. And then Pathfinder ended up being the only mission in Missour, with the program being canceled and replaced with the Mars Exploration Program. That's part of NASA's Discovery program after the loss of the Mars Observer. And then the Pathfinder base station was later renamed to the Carl Sagan Memorial Station in honor of the late and world-renowned astronomer, planetary scientist, cosmologist, astrophysicist, astrobiologist, author, and science communicator. Name it all. The Sojourner rover was named by a 12-year-old Valerie Ambroisi of Bridgeport, Connecticut, after she won a year-long worldwide competition in which students up to 18 years old were invited to select a heroine and submit an essay about her historical accomplishments. Um, the students were asked to write her in their essays how a planetary rover named for their heroine would translate these accomplishments to the Martian environment. And then Valerie Ambroisi winning essay suggested naming the rover for the 19th century women's rights activist Sojourner Truth and was selected for 3,500 essays. Now, the Pathfinder mission was a proof of concept mission above all else to demonstrate several technologies could be viable for a low cost mission to Mars, and that was faster, better, and cheaper than previous missions that were 5 times more costly. The mission proved that an airbag mediated landing, pedal and ramp rover development system, automated obstacles avoidance, a six-wheeled rocker bogie rover on Mars, and many other technologies were possible. So with this success, the Mars Pathfinder mission set the groundwork for many missions that followed over the 20 years, including the Spirit and Opportunity rovers, Curiosity, Perseverance, and soon humans on Mars. And with that, let's now get into the mission overview, Rich.
Thanks, Adel. So, the Pathfinder mission primarily had 3 major objectives. The first, to prove that the development of faster, better, and cheaper spacecraft was possible, with 3 years for development and a cost under 150 million USD for the lander and about 25 million USD for the rover. To show that it was possible to send a load of scientific instruments to another planet with a simple system and at 1/15 the cost of a Viking mission. For comparison, the Viking missions costed about 935 million US dollars, and that was in 1974. And accounting for inflation to about 1997, that went up to like $3.5 billion. So it's a lot of money. And thirdly, to demonstrate NASA's commitment to low-cost planetary exploration by finishing the mission with a total expenditure of $280 million, including the launch vehicle and mission operations.
So significantly cheaper overall, it turns out.
Yeah, actually. And in fact, why don't you tell us, Kage, a little bit about the Pathfinder Sojourner missions?
Sure, would love to. So the Pathfinder mission and its Sojourner rover carried a series of scientific instruments to analyze the following Martian attributes, which included atmosphere, climate, geology, soil composition, and rock composition. The mission was the second project from NASA's Discovery program, which promoted the use of low-cost spacecraft and frequent launches under the motto, again, cheaper, faster, and better, promoted by then-Administrator Daniel Goldin. The mission itself was directed by the Jet Propulsion Laboratory, with JPL's own Tony Spear as the project manager. This mission was also the first of a series of missions, which we have covered in the previous episodes of this mega-series, to Mars that included rovers, and was the first successful lander since the 2 Viking missions landed in 1976. Long time passed between then. So it's also worth noting here that the Soviet Union did successfully send rovers to the moon as part of their Lukenhod program in the 70s, but they tried this later with missions to Mars, which were successful in reaching Mars, but they were unsuccessful in using those said rovers for their Mars program. They never made it past a few minutes of telemetry when they first landed, I think their first mission, if I remember correctly. So, as mentioned before, this was also a proof of concept mission to demonstrate many parts of the Pathfinder lander as well as the Sojourner rover, and would be used for developing a lot of the upcoming technology for Spirit and Opportunity, which would then subsequently be used for developing Curiosity and Perseverance. So among those were especially the airbag touchdown system, and the lowering via a umbilical cable, or rather a bridle, as it was called, and dropping from not too far above the surface, bouncing around on the surface. So there were a lot of really interesting, successful technologies that were proven successful with this. So with that, just to get into a few quick specifications about uh, the lander and the rover itself. Let's actually switch over to you, Rich. Do you want to give us a quick background into some of the specifications?
Absolutely, Kage, not a problem. So, the lander itself, the whole mass of the lander is 360 kilos on Earth. On Mars, that works out at about 136 kilograms or thereabouts. And the basic design consisted of an aeroshell with a parachute, retro rockets, and airbags, and the entry, descent, and landing system as well. It was a self-righting tetrahedral lander, so that's tetrahedron, which is triangles on all sides and a triangle on the bottom. And it had an active thermal design for the lander as well, and a free-ranging rover. That was effectively the components of the entire mission. As for command and data handling, we had some integrated attitude and information management system, also abbreviated to AIM. And for computation, we had an R6000 computer with a VME bus and 22 MIPS. Wow.
Yeah, and speaking of the onboard computer, this is actually one of the other proof of concepts, because this was when I think this was the first mission to Mars where they used the radiation hardened IBM RISC 6000, the RAD 6000 CPU. And they actually built upon this for Spirit and Opportunity later. But yeah, it was actually pretty powerful in terms of space hardware goes, because it had a massive 128 megabytes of RAM and 6 megabytes of EEPROM, and the same kind of VxWorks operating system that has actually been used for all the rovers since. It's been used actually, I think, on all NASA rovers. And the Sojourner rover was actually not quite as powerful, running an Intel 80C85 CPU at a blazing fast 2 megahertz with 512 kilobytes of RAM and 176 kilobytes of flash memory solid state storage. That's, man, that'll definitely run Crysis, won't it?
Wow. Probably run Doom.
That, you know what? I would love to see that. So you know how there's been that project where they put together a real functioning Apollo computer? I want to see if there's, like, in the Smithsonian or something like that, if there's a real functioning duplicate computer from the Sojourner rover, and somebody builds and runs Doom on it. Imagine. Just imagine.
I mean, I'm pretty sure there's an entire subreddit dedicated to all the things that you can run Doom on.
Yeah, that would be the greatest thing ever. Running Doom on computer hardware destined for space.
Hell yeah.
Interesting.
I mean, the whole point of Doom is about killing demons on Mars, right?
Yeah.
I mean, yeah, actually, it is.
So, back to some of the specifications here. There was a crazy segue right there. So the computation we discussed earlier had an R6000 computer with a VME bus, 22 millions of instructions per second, and 128 megabyte mass memory. Power, it had a solar-powered cruise stage and lander, So there was solar panels on the cruise stage as well as the lander itself. So for the telemetry and command, we have the surface operations telemetry rate via the high gain antenna, which was about 6 kilobits a second. And then the surface operations command rate via the high gain antenna was only 250 bits a second, which is astonishingly slow. For propellant, we have something that we're all quite familiar with now, actually, ever since the Crew Dragon. We have monopropellant hydrazine used for the cruise stage. Hydrazine, obviously, we now know gets used in the Crew Dragon capsule as a hypergolic fuel. And we have 8 4.4 Newton thrusters and a total delta V of 130 meters per second. So, Adel, would you like to tell us a bit about the rover?
Yeah, sure. So the size of the rover is 63 centimeters or 24.5 inches long by 48 centimeters or 18.7 inches wide and 28 centimeters 10 by 9 inches tall. Although it had to squat to 18 centimeters 7 inches when stowed. The rover was the size of a microwave and comparatively is about as big as the instrument array at the end of the Curiosity robotic arm. It also has a total mass of 16 kilograms, or on Mars, the weight will be different. So it will be 6.05 kilograms on Mars. And then the mobile mass is 11.5 kilograms, and in Mars, it's 4.35 kilograms. And that's including the APXS development, or I'm sorry, APXS deployment mechanism and APXS instrument. The lander mounted rover equipment mass is 4 kilogram. That's 1.70 kilogram on Mars, including ultra high frequency modem and support structure. The autonomous navigation on board, it's using laser stripping for obstacle detection. Mobility system, it has 6-wheel rocker bogie suspension. This front bogie system allowed the rover to climb over rocks up to 20 centimeter in size, and its onboard laser stripping obstacle detection and manual driving control from Earth-based driver would let it navigate to surface up to 100 meters from the Pathfinder lander. Rich, would you like to tell us about the command and telemetry?
Sure, thank you very much. For the command and telemetry that we spoke about earlier, it had a ultra-high frequency link with the lander. So whilst the lander was processing that command and telemetry link, there's another link yet again between the lander itself and Sojourner, which is just an ultra-high frequency radio link with the lander. For the payload, it had an aft camera and 4 cameras, the APXS, which we'll come to later, and the APXS deployment mechanism. For power, it had 0.25 meter squared solar panels, or quarter of a meter squared solar panels, with a peak power of 16 watt hours and a primary battery that could store up to 50 watt hours of power. For thermal control for the warm electronics box, it had 3 radioisotope header units, which we are familiar with from our previous episodes. They use this quite frequently to keep the electronics warm on Mars. And for the surface ops times, typically they would operate between 10 a.m. to 2 p.m. on each Martian sol.
Cool. So, with that, let's talk about the entry, descent, and landing of the Pathfinder mission. So, with this, we'll have a video superimposed on top of this to show you some of these things in action. So we first start where Pathfinder and Sojourner was launched on December 4th, 1996 by NASA aboard a Delta II booster at Delta II 7925, a month after the Mars Global Surveyor was launched. Mars Pathfinder directly entered the Martian atmosphere in a retrograde direction from a hyperbolic trajectory at 6.1 kilometers per second on board a conical aeroshell capsule with an ablative heat shield derived from the original Viking Mars landers in the 1970s. This heat shield would slow the descent to about 370 meters per second or 830 miles per hour, where a supersonic disc gap band parachute was inflated. This parachute would slow the descent through the thin Martian atmosphere further still down to 68 meters per second or about 150 miles per hour. The ablative heat shield was then dropped from the aeroshell 20 seconds after the parachute was deployed. Another 20 seconds passed, and the lander and its not yet inflated airbags were then lowered from the back shell using a 20-meter or 65-foot tether known as the bridle. When the lander was about 1.6 kilometers above the surface, the onboard computer would then use the current altitude, descent velocity, and the onboard radar to determine the timing of the next series of events. At 355 meters above the surface, the airbags were inflated in a fraction of a second using onboard gas generators. The airbags were made of 4 interconnected multi-layer Vectron bags that surrounded the tetrahedron lander, which was a successful design that was used again later for Spirit and Opportunity. The onboard computer calculated the best time to fire the 3 solid fuel retro rockets in the back shell to have the lander 20 meters above the surface by the time the rockets hit a 0 meter per second equilibrium state. The computer then signaled the bridle to be cut, and the lander hit the surface at 14 meters per second with a deceleration impact of 18 Gs, and then bounced at least 15 times on the surface, reaching a height of 15.7 meters until it finally rolled to a stop. The airbags deflated and were retracted against the lander using 4 winches on the pedals. The lander was designed to right itself if it landed on a pedal, as shown in the video, where it would deploy that pedal first before unfolding the others to expose the lander and rover and begin its signal acquisition with Earth. In the case of this lander, it actually ultimately came to a stop right side up. On the next day, the Pathfinder camera mast was lifted, but they discovered a problem with the ramp deployment. One of the airbags had not fully deployed, and engineers were concerned this would cause a problem with deploying the rover. So they sent commands to lift that pedal a bit and use the winch to retract the airbags further, then lowered the pedal and deployed the ramp. With that problem solved on Sol 2, they could now issue commands for Sojourner to detach and drive down one of the ramps. And then finally, the ramps were corrugated to give Sojourner something to lock into as it slowly descended and reached the Martian surface. At this point, the Pathfinder mission could now truly begin. And with that, Rich, would you like to tell us about some of the Pathfinder mission instruments?
Sure, no problem. So, for the Pathfinder itself, which is the lander, it had the IMP, which was the imager for Mars Pathfinder, which included on it a magnetometer and an anemometer, which basically measures magnetic fields and the wind, respectively. The imager for Mars Pathfinder is a stereo imaging system with color capability provided by a set of selectable filters for each of the 2 camera channels. It has been developed by a team led by the University of Arizona with contributions from the Lockheed Martin Group, the Max Planck Institute for Aeronomy in Lindau, the Technical University of Braunschweig in Germany, the Ørsted Laboratory, Niels Bohr Institute for Astronomy, Physics and Geophysics in Copenhagen, Denmark. And the IMP itself consists of 3 physical sub-assemblies. It's got the camera head itself with the stereo optics, the filter wheel, CCD, preamp, mechanisms and stepper motors. It's got the extendable mast that it sits on with electronic cabling, and then it has 2 plug-in electronic cards. There's a CCD data card and a power supply motor drive card, which both plug into slots in the warm electronics box that we were talking about earlier within the lander. And then we have the ASI MET, which is the atmospheric and meteorological sensors, which consisted of a wind sensor at the top of the mast, a descent temperature sensor, and a top mast temperature sensor. Now, this itself is an engineering subsystem which acquires atmospheric information during the descent of the lander through the atmosphere and during the entire landed mission. It's implemented by JPL as a facility experiment, taking advantage of the heritage provided by the Viking mission experiments. Data acquired during the entry and descent of the lander permits the reconstruction of profiles of atmospheric density, temperature, and pressure from altitudes in excess of 100 kilometers to the surface. The accelerometer portion of the ASI is provided by the Attitude and Information Management Subsystem of the lander, the AIM that we spoke about earlier. It consists of X, Y, and Z axis sensors. Several gain states are provided to cover the wide dynamic range from the micro-G accelerations experienced upon entering the atmosphere to the peak deceleration and landing events in the range of 30 to 50 Gs. That's some Gs. The wind sensor on the top of the mast employs 6 hot wire elements distributed uniformly around the top of the mast. The wind speed and direction, 100 centimeters above the surface, are derived from the temperature of these elements. And Kage, how would you like to tell us about some of the Sojourner instrumentation?
Sure. So Sojourner was first and foremost a proof of concept, but it did, of course, carry some scientific instrumentation and some other instruments that were used for various other purposes. So it had an imaging system, of course, which had 2 black and white front-facing stereo cameras, which were really, really high density at 484 pixels by 768 pixels. That's a lot of image data comparatively today. So I also had one rear-facing collar camera used to make sure that it wouldn't run into anything. It would send that information, of course, back to the NASA scientist or driver who was actually driving on Mars. And when you think about that, that's really cool to think about that. There were a few people at NASA who can walk away and say for the rest of their lives, yeah, I drove a little vehicle on Mars, like sent it instructions and drove it around. That's amazing. Also on board was a laser striper hazard system. So Sojourner's hazard avoidance system consisted of 5 lasers, 5 laser stripes that were projected out onto the ground, and one laser was located in the center of the rover body and points straight ahead. 2 of the lasers were pointed outward at a modest angle from the center beam, and 2 more were projected farther outward, like peripheral vision, beyond the rover's body. And so, by looking at the shape of the stripes generated by these lasers' paths, they could then detect rocks and build contour maps of the terrain immediately in front of the camera, and then use that to help guide it for its next little bit of its journey. There's also the APXS, which was the alpha proton X-ray spectrometer. And so what that is it's a device that analyzes the chemical element composition of a sample from the scattered alpha particles and fluorescent X-rays after the sample is irradiated with alpha particles and X-rays from radioactive sources. So the variation that was used on Sojourner could also detect protons, and it was developed by the Max Planck Institute at the University of Chicago. There was also the wheel abrasion experiment. This was an experiment to determine how various materials would cope with the abrasion of the Martian surface. So on Sojourner's center right wheel, there were various thin films around 200 to 1,000 angstroms of aluminum, nickel, and platinum deposited onto black anodized aluminum strips, which were then attached in the center of the outer wheel structure. And whilst you could get some ration from the strips interacting with the Martian regolith. On occasion, they would perform more vigorous tests by locking the wheel in place, apart from the test wheel, and send the test wheel into a wheel spin while anchoring the rest of the rover. So use that to basically kind of just spin it against some rocks to do some aggressive abrasion testing against those samples, and then use onboard cameras to determine what effect it had on those materials. So, with that, Idel, would you like to go through the other two scientific instruments on board?
Yeah, sure, Kage. Thank you. Materials adherence experiment, or MAE, was included aboard the Sojourner rover to measure the degradation in performance of a solar cell as dust had settled. The experiment consisted of a small gallium arsenide solar cell mounted underneath a removable glass cover plate. As the mission progressed, atmospheric dust would settle on the glass cover plate, blocking increasingly more sunlight from striking the solar cell, causing it to produce less power. Throughout the mission, the glass cover plate was occasionally rotated away from the solar cell, removing the light blocking effects of the dust. And then the sensors measuring the difference in power output of the solar cell before and after the cover plate was removed indicated how quickly the solar cell was losing its ability to produce power, and by extension, how quickly dust was collected on the cover plate. The rotating actuator used to move the glass cover plate away from the solar cell marked the first use of a multi-cycle shaped memory alloy in a space application. Due to the high level of UV radiation on the surface of Mars, it was important that the glass that covered the solar cell would not darken. So for this purpose, they use supersil. Then the accelerometers. These were installed on Pathfinder to collect telemetry from the entry, descent, and landing velocities, and also to determine directionally upon landing. So on Sojourner, they were used for orientation purposes. Let's go to the timeline.
Yeah, so we do have a brief timeline here of a couple of Sojourner's achievements, and it starts off from about June 30th, which is when Mars Pathfinder was approximately 1.3 million miles, or 2 kilometers, from Mars, and it was traveling at a velocity of about
2.0 million kilometers, you mean?
2.0 million kilometers, I mean.
and traveling at a velocity of about 12,000 miles per hour, which is about 19,080 kilometers per hour with respect to Mars. And then on July 4th at 9:32 a.m., that's when the cruise stage separated. And then at 10:02 a.m., that's when Pathfinder began to enter the upper atmosphere of Mars, and it came in at a whopping 16,600 miles per hour, or 26,460 kilometers per hour. That is screaming some. And at this point, it began the sequence of events that would land the spacecraft on the surface. From this point on, when that craft starts to enter the atmosphere, there's a lot of heat starting to build up on the ablative materials and stuff, and it generates a lot of interference. So the only likely signal from the spacecraft will be the carrier wave itself, a single frequency radio wave. The shifting frequency of the carrier, known as the Doppler shift, will provide an indication of the decelerations occurring during entry and parachute deployment. They're just indications. They don't give you an exact, but this is another reason why the accelerometers were included, as Adel mentioned earlier. The spacecraft was also designed to send back a frequency-keyed signal following certain key events, and this signal is called a semaphore. The semaphore is very weak and isn't expected to be received in real time. However, careful analysis after the fact of the broad frequency spectrum recording of the radio signal will give the operations team considerable information on how events unfolded during the rapid descent to the surface at that time. By the way, the whole procedure takes about 4.5 minutes. Kage, do you want to take us through what that 4.5 minutes looked like?
Yeah, so that was from the video that I walked through earlier. That's the entry, descent, and landing, where the spacecraft would rapidly decelerate through the atmosphere using its ablative heat shield, deploy its parachutes, separate from the heat shield, release from the back shell, where it descended on the bridle, would pick up its current location using radar altimeter and descent velocity, inflate the airbags, fire the retro rockets, cut the bridle cable, and then bounce on the surface. So that takes us to about 10:07 a.m. At that time on July 4th, where the landing was on the landing on the surface of Mars was in RS Vallis. So the transmitter then turned off shortly after to save power, and after the touchdown, as shown earlier, it rolled to a stop. The airbags were deflated and retracted, and then the pedals opened up. Yeah, so continuing on, the Pathfinder lander did some signal acquisitions where it was preparing itself for the next sol or day on Mars. So at sunrise on the landing site, operations began on Sol 1, which is a Martian day, about 24 hours and 40 minutes here on Earth. So the transmitter then turned on, and the spacecraft sent signals to Earth through the low-gain antenna. The communication session contained telemetry from all the engineering subsystems, including the rover, and the first science data about the atmosphere taken during descent. After that, the carrier signal was received following some ground processing. Actual first information was received by flight controllers later in the afternoon. And then once they fixed the problem that was mentioned previously about one of the pedals or one of the airbags not fully, deflating, they fixed that problem, retracted the airbag a little bit further, lowered the pedal back down, and deployed the ramps. So by Sol 2, they were able to begin the next experiments. So that's when Sojourner exited from the lander. Then the next day on Sol 3, began the analysis on Barnacle Bill, as it was titled, using the APXS. And then Sol 4 was when they started the analysis of Yogi and the Scooby-Doo rocks. After that, it gets a little bit fuzzy about when the next series of events happened, because one has to remember that this was back in 1997 when they weren't really publishing a whole lot on the internet about various missions to space. And so the actual original website for the Mars Pathfinder mission looks like it came from GeoCities or Angel Fire or something like that for the listeners old enough to remember those. So it's not very replete with information. It's just about what was going to happen and not so much about what did happen. So from here, it gets a little bit fuzzy. But what is known is that the mission was supposed to last for only about 7 days, maybe up to a month. And they didn't expect it to last that long. It turns out that it actually lasted for several months longer than they anticipated. So they continued with various experiments where the lander ended up sending more than 2.3 billion bits, or a whopping 287.5 megabytes of information, including 16,500 pictures. And it made 8.5 million measurements of the atmospheric pressure, temperature, and wind speed. So, by taking multiple images of the sky at different distances from the sun, scientists were also able to determine that the size of the particles in the pink haze was about 1 micrometer in radius, which the color of some of the soils was also similar to that of an iron oxyhydroxide phase, which would support the theory of a warmer and wetter climate in the past. That has since been, I believe, confirmed through various rock sample measurements done by, was it Curiosity? that was able to determine the wet climate that had existed in the past? You have to remind me on that, Rich.
So actually, Opportunity landed on evidence of water straight away
Oh, right,
because
yes.
because in Eagle Crater you could see the rivulets form down the rocks. So straight away, boom. That's why they called it the hole in one.
Gotcha, right. Yeah, forgot about that. So the Pathfinder mission carried a series of magnets to determine or to examine the magnetic components in the dust surrounding it, and that was actually again repeated. I think that was in the Spirit and Opportunity rovers. Also had magnets on them, if I'm not mistaken.
That's correct. Yeah.
Yeah. Eventually, all but one of the magnets developed a coating of dust, and since the weakest magnet did not attract any soil, it was concluded that the airborne dust did not contain pure magnetite or just one type of magmite. So the dust was probably an aggregate, possibly cemented with ferric oxide. So using much more sophisticated instruments, Mars Spirit, the Spirit rover, actually found that magnetite could explain the magnetic nature of the dust and soil on Mars. Magnetite was also found in the soil. And the most magnetic part of the soil was dark, since magnetite is also very dark. Using Doppler tracking and two-way ranging, scientists added earlier measurements from the Viking landers to determine that the non-hydrostatic component of the polar moment of inertia is due to the Tharsis bulge, and that the interior is not melted. So the central metallic core appears to be between 1,300 kilometers and 2,000 kilometers in radius, and they've since continued similar kinds of experiments with, I think that was with Curiosity, that they started looking into um, more core-based investigations. Also, I think
Actually, Insight just recently published findings about the core on Mars, its size and
okay.
whatnot. It was the Insight mission that recently produced that.
Yeah, it's hard to keep track of which one of the missions on Mars has discovered what, but they've all discovered a lot of things, and all of this really started with the Pathfinder mission and its Sojourner rover. It really kicked off a lot of amazing things for the next 20 years. And with that, I'd like to hand over to Adele to give us the closing remarks on the Pathfinder mission.
Yes, thanks, Kage. So, the Mars Pathfinder mission set the groundwork for many missions that followed over the next 20 years. This not only included the Spirit and Opportunity rovers, Curiosity, and most recently Percy or Perseverance, but also many orbiters and landers. The Mars Climate Orbiter and Polar Lander, both of which unfortunately failed. Mars Odyssey Orbiter, Mars Reconnaissance Orbiter, Phoenix, Maven, Insight, and those are just the NASA ones. There were also Mars Express, Rosetta, Phobos Grunt, and Yinghua 1, Mars Orbiter ExoMars, Emirates Mars Mission, and Changwen 1 from ESA, ISRO, Roscosmos, CNSA, and MBRSC. So, the success of Mars Pathfinder inspired 20 years of missions to Mars, most of which were successful and have paved the way of humans to set foot on Martian surface in the next 10 years or perhaps less.
Crazy, isn't it?
Yes.
It's amazing that we're finally getting to that point where the next missions to Mars might be to send humans there. And
Yes.
all this really started because of sending some robotics to Mars to make sure that it would be safe for us to do so, and learn how we could do so. So thank you to the Pathfinder mission, to the Sojourner rover for well, being the Pathfinder than it was to bring us to these next things coming up.
Thanks for saving Matt Damon in The Martian.
That too.
Speaking of new things to come, Kage, this is the very last episode of the Rover Mega-Series. Would you like
true.
to tell our audience what we have planned coming up for after?
Absolutely. So, once again, thank you all for joining us on this long mega series about Mars rover missions. And with that, we will be closing this mega series, and we'll actually be starting a new mega series. But it's not just going to be a Becoming Multiplanetary mega series, but it's actually going to be beyond that, beyond even Total Space Network. We will be partnering with Sebastian and Zhichuan from To the Future, who will be working with us on a collaborative series of, I believe it's 7 episodes, if I remember correctly, titled Humans in Space. The first episode will start on To the Future's YouTube channel, where they will begin the series, and then we'll bounce back and forth between Becoming Multiplanetary and To the Future to discuss the development of humans in space all the way up through what's coming next. So, really looking forward to that. That's going to be an amazing thing to do with Sebastian and Jeshwan. Really happy to have them on board with this. It's going to be an awesome multi-part series. So if you haven't yet checked out To the Future, please go check them out on YouTube. Give them a like and subscribe, and look forward to that showing up there. And then every other week, the next episode showing up here on Total Space with Becoming Multiplanetary. So with that, I have been Kage. Thank you so much for joining us. If you like what you've been watching or listening to, please also make sure to check us out on totalspace.net, where you can also find all of our socials. For example, you can find us on Twitter at TotalSpaceNet. And with that, I will now hand over to Rich.
I've been RichLB, co-host of Becoming Multiplanetary as well. And I'd also like to hand off to Static Fire Girl, or Adel, to say goodbye as well before we wrap up this episode.
I've learned a lot on this series, and thank you so much, guys, for inviting me. And this has been Edel or Static Fire Girl. You can check me out in Twitter at GalStatic.
There's one more thing, Rich. You know the thing. Do the thing, Rich.
I do know the thing, yes indeed. So as always, at the end of each episode, we take a moment to say thank you to all of the Patreons subscribing to Total Space. Their funding really does make everything possible here. Thank you guys so much, and without further ado, here we go. We have Anthony Mann, we have Warhawk, we have Adrian Moisa, we have The Angry Astronaut, we have Howard Walker, we have Sammy Oscuro, also known as Stinger NSW, we have What About It, we have Jishwan and Sebastian from To the Future, we have Gio Pagliari, we have Framrick, we have Susie R, and we have Marco Makuch. And that is all of the Patreons we have here so far. You can see their names scrolling on the side. And yes, seriously guys, thank you so much. You guys really do make this happen.
Absolutely. All right. So yeah, thank you for joining us for this Rover Mega Series. If you like, also check out the earlier episodes, and check out the upcoming series with us and Jishwan and Sebastian, To the Future, as well as the other episodes on Total Space Network, Deep Dive, and the Space Update. So until next time, see you around.